Okay, Chapter 7, Section 4, Compound Interest. Let's talk about annuities, page 3. Annuities are often used by individuals to save money to pay for things like college expenses, vacations, home improvements, and most commonly retirement. Businesses and governments set up annuities to pay future expenses like expansion, new equipment, healthcare costs. An annuity is a savings investment plan in which the investor makes regular fixed payments instead of depositing one lump sum in the beginning. Okay, something you pay into. So a total amount accumulated, which is payments and interest, is called the future value of the annuity. So it's still a capital A. The new variable, capital R, is for regular or recurring payments. So R now stands for payments. This lowercase r is still rates, okay? And this is the formula for annuities future value. So if you're working in Alex, we have a lot of formulas. If they use the word simple interest, that's one formula. Compound interest, that's one formula. Effective rate, that's one formula. Future value of an annuity, that's a different formula that has an R in it for payments. Okay? So make sure you have them handy. Let's look at an example of this. Find the future value of annuity when the payment is $275 quarterly. And the nominal rate or stated rate, or R, is 0.065. The term is 6 years. Find I. How much would you invest at the end of the first year to get the same as 5 years in a regular savings account, compounded quarterly? We'll get to that in just a second. All right, so let's start off with the future value. Find the future value of an annuity when the payment is $275. Okay, so here's our formula. We're going to start substituting our uppercase R. There's a 1 in the formula, plus our interest rate. Our N, it's compounded quarterly, so that's a 4 times the term, which is 6. Okay, don't forget to come down and do that -1 that we had to do in the effective rate. Okay, and then on the bottom, this is the same as this. So if you do it piece by piece, calculate what this is out of 1, and you get this number. Okay, then you need to raise it to whatever this number turns out to be, -1. Now this is going to be a lot of digits. So if you want to, you can break this down, put this number in your calculator, raise it to the 24, make sure you come down with the arrow and put a net -1, and you'll get this number here times this number and divided by that number. So keep it all in your calculator. You can do it all at once if you want to. It's quite difficult, but you can. Let's see if I can work this out. 275. See these extra brackets here? That's if you're using your calculator. So it's going to look like that. You're going to need another one. Divided by 4. Close that one. Close this one. Raise this to... You can do it separately if you have to. Okay, go over in your calculator, come down and put the 1 and close. The final closing one isn't as important as all the beginning ones, but see, this is done. So that's telling your calculator what the orders of operation is, and you should be getting that top number. Let me do it in my calculator so I can get that number. 275 parenthesis 1 plus parenthesis 0.065 divided by 4, close parenthesis, close it again, raise it to open 4 times 6, close parenthesis, over to come down, -1, enter. I got 129.898437. I'm assuming this number is correct here. So divide that by 0.01625, and that gets me that. Okay, future value. Now, there's a lot of questions up here. That's the answer to A, future value. B says find the interest earned. So this is my future value, and you put in 24 payments. Sorry for the phone thing. 24 payments. Oops, sorry. 24 payments. Because where did I get that 24? This is the R. Okay. This is the 6 times the quarterly. So this is TRT. I put it in the right. Hang on. This here is your N. Sorry. And your T multiplied together. Okay. Times the number of payments. 4 per year for 6 years. Times, we put in $275. So that's going to be this number. Subtract it, you're going to get this in interest. Okay. This is how much you deposited in payments that you made. And this is how much interest you earned. So that is B. C, how much would the savings account at 6.5% compound quarterly be? Compounded quarterly. That's all. Regular savings account, not an annuity. Use this here. We're not making payments. We're just finding out what it would be compounded quarterly. So we put the future value in for A. How much do I have to put in if I invest that amount at the end of the first year and get the same return for 5 years? So this is your term is 5 years, not 6, because you're putting it in at the end of, but you're still being compounded quarterly. You're still being, and that's still your interest rate. So you can figure out all of this, get this number, okay? Divide both sides by that number, and you should get the amount of principal you would have to put in after the first year to earn the same amount. That would be your one-time future deposit. Okay? And we are definitely going to be practicing them on the next page.